I'm Bruce Cardwell. I'm with Rosenberger North America, and I'd like to speak a few minutes about footprint optimization and its use with our connectors to enhance your design. I've prepared a brief application note, and I can hand out a few of them after the show if you'd like. I wrote most of it. Our marketing department made it a little bit pretty, but make no mistake about it. This is insomnia reading, so if you have trouble sleeping, feel free to pick it up, and I assure you, you will go right out. Footprint optimization is a service that Rosenberger has offered for many years now. We use it as a service for our customers, and our customers benefit and they achieve with our footprint optimization high performance out of our printed circuit board connectors. This discussion today, I'd like to talk about what footprint optimization actually is and how it is different from just the standard footprint that is often outlined in a connector manufacturer's product. Secondly, I'd like to discuss briefly some of the assumptions we make when we design a connector and some of the shortcomings of a standard footprint. Lastly, I'd like to discuss and outline what type of information we need from our customer so a good footprint optimization can be realized. Lastly, in this application note, and this is also on our website, the rosenbergerna.com website, there's a glossary of terms used in footprint optimization: grounded, coplanar, waveguide, things like that, aperture, etc. Okay, standard footprints. A standard footprint is something that a connector manufacturer such as Rosenberger will look at when we design a connector. It's a layout that is something that could be, but not necessarily is. A standard footprint often looks like, and I'll just use this mini SMP as an example, the 18S101-400 L5. This is a great product. It's a leaded product with a center conductor that's surface mount. A standard footprint for this type of product would represent and look like very much like the bottom of the connector. And you can see right here, you've got the four legs and you've got the surface mount connector. Basically, that is what a standard footprint is. It mirrors what the bottom of a connector looks like. What are some of the assumptions we make when we design this connector? Well, typically, in this particular case, our connector engineers would assume that this is going to go on a grounded coplanar waveguide, which is to say there's a trace, there's two planes adjacent to it, and then one underneath a specified distance, probably no aperture. And I'll go over what some of these terms mean shortly. What are some of the shortcomings of a standard footprint? Well, a lot of times, and I hope everybody can hear me, a lot of times a standard footprint can go anywhere from, could use a high performance microwave material such as a Rogers product, for instance, or something as easy or as common as FR4. The shortcomings of FR4, for instance, it's a great mechanical product, but FR4 working at, say, 500 megahertz versus 4 gigahertz is a whole nother world. It's lossy, and the impedance it will change as a function of frequency. So a standard footprint may or may not be useful for applications. And by the way, we have done footprints all the way up to and beyond 100 gigahertz. Let me see my notes here. Let's explore just for a moment what the PCB materials are and why they are important. In my application note, I have FR4 listed, an RO Duroid, which is trademarked Rogers, 5880, and then an RO 4350B. What's the dielectric constant? The dielectric constant is, of course, something that maps directly to the velocity of propagation, and the dissipation factor, while related to the dielectric constant, will be an indication of how lossy the microwave material is. Well, FR4 has a dissipation factor of 0.0195. Seems like a small number, but now when you look at the high performance Duroid 5880, it's 0.0005 to 0.0012. 2 orders of magnitude smaller than an FR4. Another high performance material, the RO 4350B, 037 to 0031. Very small, very low loss. So ideally, you would like your printed circuit board layout to be as lossless as possible, and also be consistent over the entire frequency range that your connector is working and operating. So, in summary, you want to optimize your footprint to optimize not only return loss performance, but also insertion loss performance. What does an optimized footprint layout need? Well, for us to optimize a footprint, you have to first identify a connector that you're going to use. Sounds easy, but sometimes customers are torn between several constraints. There could be a mechanical constraint, there could be an electrical constraint. Once you select your connector, we require the following information. Of course, your name, contact information, the connector you're going to use, whether you're going to place this connector on the surface of the board, or in some cases on the bottom of the board, and some of our connectors actually on the top of the board, and they go through to the bottom, and vice versa. When we're optimizing a footprint, we'll require the stack up, the PCB stack up, or what's that going to look like. Your printed circuit board designer will provide that to you, and then you'll have to provide that to us. We have a form. It's an Excel, it can be an Excel spreadsheet or an editable PDF. We'll provide that you provide that information to us. Of course, the frequency range of interest that you need, and then send that to us. A note here on cost of optimization. Printed circuit board footprint optimization is not free, and it's not generally inexpensive for us to perform. Many times, though, after a qualified lead comes to us, and there's been some discussion on what the customer needs and how good the demand is and what the opportunity is for us, we'll generally waive the footprint optimization fee. Provide this information to us, and this is kind of what it looks like, and you can come up and take a look at this if you'd like. Usually, footprint optimization takes 2 to 4 weeks, depending on our workload. Our signal integrity people are quite busy, and we keep them busy. I personally keep them busy, but we have several other product managers that work for Rosenberger that keep them busy too, so we have to pine for attention from the signal integrity group. So once you provide that information, you obtain your footprint. What is the work product that we hand you back? Generally speaking, it's a PDF, and you can see on this PDF a cross view of what the connector looks like on the printed circuit board. So it's a cross section, and this is a surface mount part. You'll see what the layers of the design will have to be to achieve performance. Next, we'll have another page, and the other page will be what your printed circuit board layout should be. In this particular case, layer 1 is right here, layer 3 is like this, and then layers 4 through 8 are like this. If you lay out your printed circuit board according to the design that we've optimized, we predict the performance right here. This is your return loss, and your insertion loss is up at the top. How accurate are these results? It's been my experience that 40, 50 gigahertz and below, we have about a 95% correlation. It's pretty good. Occasionally something will fall through the cracks, and we have to go back and look at the design. And of course we will do that for you should that need arise. But generally speaking, these things are very very accurate. Above 50 gigahertz is a little bit, it's another world, and sometimes there has to be some tweaks. So, in summary, Rosenberger's Footprint Optimization service is a cost-effective, high-performance way of helping to manage your designs. It takes 2 to 4 weeks to do, and we have a very good track record. We've been doing this service for many, many years, 20 years maybe, and we have a large library of PCB materials and a very experienced staff, not only in Germany, but also in the United States. Lastly, I was going to discuss some of the glossary of terms that I was talking about. At the back, at the end of this footnote, we go through those. Aperture, for one thing, and the aperture, which I was talking about, you'll see this small cutout right here. So directly under the printed circuit, right under the printed circuit board's first layer is the trace, and we want to keep that open to enhance the return loss performance. There's many other things in here that I discuss: encrypted model, footprint, grounded coplanar waveguide, the whole 9 yards of definitions. Are there any questions? Well, I appreciate your time. Thank you for coming. If you have any questions, please stop by and talk to one of our booth staff, and I'd be happy to help you.